All right. Good luck.
So let's look at a really very interesting concept which we have looked up in our previous classes, and let's build up on that. So up till now we have seen what NameNode is and how it stores its metadata, and it's really very important to understand how the metadata is arranged. So up till now we looked at there are two main kind of metadata, two main metadatas which NameNode takes care of. The very first one is the metadata about the files. What does it mean? Let's say you have a file hinfo, how that file will be stored in the name node. So it will have, let's say, the name of the file, the permissions, who is the owner, and the blocks mapped to it, right? So this is one kind of metadata. But where these blocks are, let's say block 1, block 3, block 5, on which data nodes they reside, there will be another metadata which will sit in the memory of the name node, which is called bitmap. So which will be kind of a mapping between the blocks and your data nodes. So bitmap is built up dynamically by the name node when the name node comes up, and it is never persisted to the disk. So what is persisted to the disk? Only the file metadata, right? So the files and the blocks which are mapped to that file. So let's have a look at where that metadata is and how that works, because it is really very important to understand how metadata is stored and how the checkpointing happens, right? So we'll understand what checkpointing is. So let's say currently I'm sitting on my name node. This is the same host which we have used till now. So I'm on my name node, which is nn1.cluster1.com. And if I do Hadoop dfs admin hyphen report on this, so I see that I have three data nodes, and we have already configured here rack awareness, right? Which we have seen in our other sessions as well. So our nodes, they are set up into different racks. You can see rack 1, rack 2, and another data node which is in rack 2. So how the distribution of blocks will be, it will based upon the rack awareness algorithm. But the most important thing which we have to talk here about is how actually the name node stores metadata and where it actually stores, right? So we looked at that the config file where it goes, right, from our previous classes, it goes into a location which is defined by dfs.name.dir, right? So this parameter has changed in the recent versions, which we will take care when we go to our Hadoop 2.0 framework. But for the time being, this parameter, which is dfs.name.dir, will solve the purpose. So the parameter, it defines that metadata will be stored at slash data slash name node, right? So let's look at what this location actually has. So if I do an ls-l on the location, so you see that it has some directory structure. So let's go a little bit deep into the directory structure and let's look what actually it contains. So it contains mainly 4 files, so out of which fs time will always be standard. But the most important files here are edit file, which is our journal file, right? Journal file means whenever you make changes or whenever you write data to the SDFS, everything goes into this edit file, which is a journal. And fs image is the image with which your name node booted, right? So if I do here jps command, you can see my name node is up, right? And edit will contain the entries of whatever data we wrote. So let's take an example. If I create a simple file, vi test file, and I write some text, let's say this is file test, and I copy this file onto Hadoop, right? I copy this file, let's say to SDFS, and I do again ls-l on the this directory structure. So what is happening here? Depending upon the size, how much data we wrote, right? This file was very small. If I do Hadoop hyphen fsls on my HDFS file system, you will see that there is one more file created, right? So one thing to notice here is Let me give you the output in human readable form. So it is showing me that edits, the size of the edits journal is around 1.1 megabytes. But my fs image remains constant. Constant means the image size with which the name node started. So how will I do a checkpointing? Right. So the checkpointing is the process of merging the edits and the fs image together. Right. Why we need to merge that? So we have already covered that in theory. Why it is important? Because when the name node comes up, if my file is very large, so it will take very long for the name node to boot up. So when does the checkpointing happen? There are few scenarios. One is if I do simply hadoop hyphen daemon dot sh stop name node and start back the name node, we will see what happens to the edit file. So look closely at the size of the file. Right. So if I do ls again on this directory, see this has been emptied and whatever content was there has been moved to the fs image. So you see that checkpointing happens whenever the name node comes up. So this might not be the right thing to do in production, right? So let's say I want to do a checkpointing of my edits journal with the fs image. So I cannot just simply go and restart my name node daemon in my production cluster, right? So it will be an outage kind of thing. So how we can do that? There are few ways of doing, for example nave save command, but the most common way of doing this is setting up a secondary name node, right? So let's look at first the theory part, what secondary name node is and what exactly it does, right? So let me give you a concept here first, then we'll go into. So as we saw that secondary name node is not a hot standby name node. So do not be confused by the name secondary. So it is not a highly available name node. Although in our later versions of Hadoop 2.0, we have a secondary name node built into our another highly available name node, but in Hadoop 1.0 framework, secondary name node just does housekeeping and checkpointing. So what does it mean? Secondary name node will connect to the primary name node at a defined interval. So by default, the interval is 1 hour, but it is a configurable parameter. What it will do, it will fetch edits and fs image from name node, pull it to itself and do a checkpointing, means it will merge the edits and fs image and push it back to the primary name node. So how this process happens? So let's say, so we saw on the primary name node, we had two important files. One is edits file, which is the journal file, and another one is the fs image file. So fs image file is the file which will not change, right? Writes do not happen directly to it. Write happens directly only to the edits file. So the primary name node holds a lock on edits file, not on the fs image file. So when the secondary name node wants to do a checkpointing, it can fetch fs image directly because it is not locked by the primary name node. But what happens to the edits? Because writes might be happening to this, right? Your Hadoop production cluster might be heavily loaded and there might be a lot of writes happening in a production cluster. So what needs to happen is the primary name node rolls a new file which is called edits.new and puts a lock on it and releases the lock on the edits file. So both these files will be pulled by the secondary name node onto its local system, means a location which is a configurable location. I will show you where it will pull it. So these two files will be pulled in onto the secondary. It will merge the edits and fs image, and it will push it back to the primary. So it will again be renamed to fs image and edits.new will be renamed to edits file. So what is happening during this time frame? There might be some writes happening to on the primary name node cluster, right? So there will still be some edits, file data in the edits, but it will be minimal. So this is what secondary is doing. So let me show you on the system. There's a lot of details which we will cover as we go along the course, but let me show you what secondary does and how we set up. So currently I'm sitting on a box whose name is snn.cluster1.com. So to ease out the naming convention, we have given the name secondary name node SNN. So its IP is 192.168.1.68 and our primary name node is nn1.cluster1.com and its IP is 192.168.1.70. So now let's look at how the checkpointing happens or how the secondary works or how we configure secondary. So let's move to the config directory. So directory structure remains standard throughout our Hadoop configurations. So we have already set up our name node and data nodes as we saw in our sessions. So same config files we have copied to our secondary. So if I open the vi core-site file, here what we have configured, same thing what we have done till now. Here we have pointed the core-site to wherever my name node is, wherever my primary name node is. So on the secondary, I'm telling my primary name node is at this host name and this port, right? So you can contact the primary on the this port. So one important thing which we have to look here, another important, very important file is htfs-site file. So what we are telling here, so as we saw, every daemon has a web server built into it, right? The primary name node has a web server, the job tracker has a web server, the secondary name node has a web server built into it, so which runs at predefined ports. So let's say if I want to access my name node's web server, which we have shown, which we saw till now. So let me show you, and I will give the port number, right? So I can see this is my primary name node. So this is the web server of my primary name node. So what is happening here? What this parameter is telling me, how the communication is happening. Actually, the edit file and the fs image file, they are copied using http get and post calls, right? It's a simple REST API. So what it does, we need to configure, or we need to tell where the web servers for each of the daemons are. So I'm telling the web server for my primary name node by saying dfs.http.address, the host name and the port of the web server, right? It's the same port number wherever my web server is running. I'm giving the same port where it is running, right? So this is my port. And for the secondary name node, also I'm telling where the web server for my secondary name node is running, so that they can do a post and a get call. So we will go into detail why we do this as we go along the course. This is the default checkpointing period, so which is by default 3600 seconds, which is 1 hour. I can configure this parameter. So usually 1 hour is a good enough time. Then I configure the locations where my secondary will pull in and store the data. So I'm saying fs.checkpoint.dir and fs.checkpoint.dir edits, right? So this is the directory where it will be pulling in the edit files. This is the directory where it will be pulling in the fs image file. After copying the files from the primary name node to its local hard drive, the secondary will merge them and push it back to the primary. So let's see how actually this is working. So let me show you the timestamp on the primary side. So it will be easy for you to relate. So if I do ls-l on the path of my metadata store location on my primary, so I'm doing this on primary nn1. So let me do a checkpointing here. So how you do a checkpointing? Obviously, one way is I can start my secondary daemon here, secondary name node daemon, and wait for, let's say, 1 hour for my checkpointing to happen. But before that, I have to make sure that the configuration which I have done on the secondary works. So I can do a manual sync up from the primary to the secondary by executing the command Hadoop secondary NameNode checkpointing force. So I'm forcing a checkpoint. So if I hit enter here, so what it will do, it will contact. So if you look at the details here, so it is telling where it is pulling the data, where it is contacting. So it is saying it is posting over a URL to the primary name node on this particular port. And if I do ls-l on the locations which you have configured, right? So you will see it has pulled in data, right? So look at the timestamp here, 22, 39, 38, right? So similarly, let's look at the another directory, right? So here it has pulled in the fs image, right? So look at the timestamp here. So timestamp on the primary is 30, right? When we before running the command, checkpoint command. But now if I look, so this timestamp would have also been updated. Why? Because secondary would have pushed back these images back to the primary, right? So if I go here, see the timestamp here. Timestamp matches here. So it is pushing back. But you might ask here, why I do not see the intermediate stage, right? Why I do not see edits.new? Well, this is a really interesting thing. And as we go along the course, we will see a lot of details, how it works, what goes in the background. But let me quickly show you how this is coming. So let me comment out this line here, for example. Let me take out the configuration for my secondary web server, right? So I moved out the entry which tells me where my web server for my secondary is running. So now let's do the checkpointing command again. So you will see a very interesting thing coming here now. So you can always obviously read the logs and see, right? So it will be giving you an error, right? So let's do ls again. So you see edits.new here now. So why this is happening? So this is an intermediate state. So why we were not seeing this state initially? First of all, the data which we have on this cluster, which is our test cluster, is very small. So the checkpointing happens very quickly. The edit file was not big, so checkpointing was happening very quickly. But now, why it is not able to roll the edits.new back to edits? Because we have removed the important line here, which was talking about where my web server for my secondary is running. So what happens when I remove the entry for the web server for my secondary name node? What it does, it is not able to do a post call from by making end-to-end connection. It is although able to do a pull or get call, but it is not able to do a post call because it is trying from a local host, right? And when it goes and connects to the primary name node with a local host, so it does not understand what local host is. So you have to have a fully qualified domain names or IP specified for you to address this out. So if I put this parameter back, so let me just put this parameter back into this. So you will see if I put this parameter back into the config file, so it will start working, right? It will. It's if I enter this parameter and I simply do a checkpointing here again, right? So now you see it is able to transfer the image, right? So it's saying opening a connection to the primary name node. And if I do ls again here, so you see it has gone. So we will understand as we go along the course what goes in the backend, right? So this is an overview how the secondary is working and how it is doing checkpointing. So this is what we are talking in this slide. So how the rollback is happening and how the primary is talking to the how primary and the secondary are talking to each other. So the another important thing to keep into mind is how you know what is fs image, right? So what data fs image contain? So fs image is kind of your metadata or similar to inode structure, right? So we have discussed that how the inodes work in a Linux system, right, on an ext3 file system. Similarly, we have a data structure which sits in fs image, which maps your blocks to the file. So let me show you. For example, let's say I want to look inside the fs image and see what exactly fs image contain. So if I can execute the command similar to, I can say hadoop oiv. This is image viewer, right? So if I hit enter here, and if I do cat on fs image, so it will show me what entries my metadata has. So these entries are same as compared to the command which we execute here, right? But this is, we are directly looking into the metadata. I cannot go and do, let's say, data name node current fs image here, right? If I go here and try to do an fs image cat on that, right, so it is gibberish. I cannot read that file. But if I use oiv viewer, I am able to view what's inside it. So this is very important, especially when we are doing Hadoop upgrade, to be sure that our images are consistent. And there are a lot of things which we talk about. Let's say the fsck status, a lot of things which go into picture. So in this command, we can give a lot of formats. We can give output into an HTML format. We can give an output into an XML format. So there are a lot of format it takes. So as I was telling you, as we have discussed till now, if I do dfs admin hyphen report here, we have already configured rack awareness, right, as we have seen till now. So we can go a little bit deep into what exactly happens at the, let's say, a file system level. If I do fsck on my file system, it will tell me what is the consistency level, and I want to check, let's say, the consistency about a particular file, let's say test file which we have copied. I can check for that, right? I can also do at the files level, right? It will tell me this file size is this, it has one block. I can check for blocks as well, right? So it is telling me how many replicas it has, this particular block. I can also go by location, right? So it will tell me the locations also where it went. So currently our application is set to one only, so that's why it is not going to various data nodes, right? But it is really important to understand that. So this is a quick introduction to our primary and the secondary name node communication. But as we go along the course, we will see what goes at the backend and how the secondary name node is replaced in our newer Hadoop 2.0, because over there we have high availability. So in high availability, what we will do, we will configure two name nodes which can fail over. Let's say if one name node goes down, the other will serve the request, and the second name node acts as a secondary as well. So when you are configuring high availability, you do not need to have a secondary name node. So it will be doing the checkpointing for you, right? So this is what the configuration is. So I hope you had a good overview of how the primary and the secondary talk and how the checkpointing works. So thank you very much for this for attending the session. Thank you.